Hello everyone. In this video I'm going to speak about redox equations. Let's get started. First of all, we have to know that we have two half equations, oxidation half equation and reduction half equation. The oxidation half equation could be presented in different ways. As we can see, all half equations that we have here are reflecting oxidation. You can see here from a neutral atom to positive ion, from positive ion to more positive ion, from negative ion to a neutral molecule, from negative ion to less negative ion. But what is in common between all of them? All of them are accompanied by an increase in the oxidation number. The oxidation number in the first one has been changed from 0 to positive 2, from positive 1 to positive 2, from negative to 0, from negative 2 to negative 1. So all of them are accompanied by an increase in the oxidation number. And of course, all of them have electrons in the products. So these are the two main features in any oxidation half equation. What about the reduction half equation? As we can see here, we have a neutral molecule, it became negative ion, negative became more negative, positive ion became a neutral atom, and we have a positive ion became less positive ion. What is in common between all of them? The reduction reaction or the reduction half equation is represented by it has a decrease in oxidation number, as we can observe here from 0 to negative 1, from negative 1 to negative 2, from positive 2 to 0, from positive 2 to positive 1. So we have to show, if you would like to write a reduction half equation, or if you would like to detect if the equation or the half equation that we have here is a reduction half equation, we have to show that there has been a decrease in the oxidation number. And of course, all of them have electrons in the reactants, which means that they all are accompanied by, all these half equations are accompanied by gain of electrons. Let's check an example here. Fe2 positive plus MnO4 negative, asking you to write half equations for the following reactions. What you should do here, you have to check the reactants and check also the products. What has happened to Fe? So we have Fe2 positive, it became Fe3 positive. What has happened? It lost an electron, so there must be an electron here. And this half equation is representing the oxidation half equation, because it was 2 positive, it became 3 positive, so it lost an electron. And I have to be careful when I'm writing it. I shouldn't write iron. No, it is not iron, it is iron. Fe2 positive, it became Fe3 positive. What about the reduction half equation? We have here Mn. So MnO4 negative. We need to check the oxidation number for Mn here for manganese. So we need to break it down. So Mn plus 4 oxygen is equal to negative 1. It's a charge. So Mn minus 8, why minus 8? Because we know that oxygen is negative 2. Negative 2 by 4 is negative 8 is equal to minus 1. So Mn is equal to plus 7. So the reduction half equation could be represented as Mn 7 positive, it became Mn2 positive. And this reaction is accompanied by a gain of 5 electrons, And this is the reduction reaction. Let's check the next equation. So first SN2 positive, it became SN4 positive. What has happened here? It lost 2 electrons. So this is oxidation half equation. What about iodine? We need to figure out or to calculate the oxidation number for iodine in IO3 negative. So it's I plus 3 oxygens is equal to -1. I plus 3 by -2 is equal to -1. So we have here I, we have -6, so it's P positive 6 minus 1. So the oxidation number for iodine is plus 5. So we can write it as I 5 plus, it became I negative. What has happened here, I 5 plus gained 6 electrons, and this is representing the reduction half equation. So what you should do, you should check the reactant and what has happened to this particular reactant in the product. You can directly check it by comparing the oxidation number. If this equation, half equation, is accompanied by an increase in the oxidation number, so it's oxidation. Increase in oxidation number, oxidation. Decrease in the oxidation number, so it is reduction. All oxidation half equations are accompanied by an increase in the oxidation number, while the reduction half equations are accompanied by a decrease in the oxidation number.